Hi everyone, today we're going to conquer two's complement representation, but before I start, can I ask that you click on the like and subscribe button below so that you don't miss out on any of our videos. Right, okay, so we're looking at converting negative numbers into two's complement format. I would recommend that you watch the previous video on sign and magnitude representation where we looked at a different method of converting negative numbers into binary representation. So today it's two's complement, and as you can see, we're starting with the most significant bit as a number, but it represents minus 128. Now, just referring back to the previous video where we were using sign and magnitude, the most significant bit was a sign, the plus/minus. Okay, and the rest of the number was magnitude. Here, all of the columns are numbers. Minus 128, 64, 32, 16, 8, 4, 2, 1. Okay, so starting with that, if we are going to represent a negative number, it will have to be placed there or start there. So we'd have to have a 1 there. Okay, and then like a timeline, if you remember from primary school, where if you were adding, you moved along towards the right on the timeline. Here, you start with the minus 128 and you add as you go along. Okay, so we're going to start off with an example, and we're going to start off with minus 100. So to represent minus 100 in two's complement format, you place the 1 under the 128, or minus 128, because that's the only column you can represent a negative number. Okay, and now we add as we go along. So minus 128 plus 64 wouldn't work, plus 32 wouldn't work, but minus 128 plus 16 plus 8 plus 4 will give you minus 100. Okay, so basically what you are doing is just adding as you go along. Minus 128 plus 16 plus 8 plus 4 would give you minus 100. You can check that on the calculator. Of course, as you know, the OCR computer science does not allow a calculator, but while we're working out, we can. I will be showing you a shortcut or very easy method to convert positive numbers into two's complement as well. So please make sure that you watch the video up until the end. Now we're going to have a go at another number, minus 55. So again, you need to put the 1 there because that's the only place where we can represent a negative number. So minus 128 plus 64 gives you minus 64, difference of 9. So that 9 would be here, and I'm just going to put zeros. And if you double check that, minus 128 plus 64 plus 8 plus 1 should give you minus 55. One more example. Minus 62. So again, we put the 1 where you've got the minus 128. Now, here we're going to add 64 to it, so that gives us minus 64. Okay, 128 plus 64 is minus 64. To get to minus 62, we need to add another 2. So place the 1 there, and all the rest are zeros. So 1 1 as in 1 1 0 0 0 0 1 0 gives you minus 64. And again, check that on the calculator if you're not 100% sure. Minus 128 plus 64 plus 2 will give you minus 62. Now, these could be 1 markers or 2 marks in the exam. So that's fairly straightforward. However, sometimes they might ask you to represent 62 in an unsigned 8-bit binary number. Then they'll ask you to represent minus 62 in two's complement. So there's a way that we can do that, because if you've already converted 62 into an 8-bit binary, we can easily flip that into two's complement, and I'm going to show you how to do that. Right. So let's have a look. All right, so we're going to start with 62. Now, the first thing I'm going to say is that You're never going to be representing positive numbers in 2's complement. I've not seen that so far. So normally they'd ask you to represent 62 in an 8-bit binary number. If it was just standard 8-bit binary number, that would look like, so 62 right, so that gives us 62, nice and easy. So let's say they ask you to convert 62 into an unsigned binary number. That's what you've done. And if the next question is represent 62 in 2's complement format, then there is a very easy rule that you can follow. So now we want to represent minus 62. We've already worked this example out, but I'm just going to show you the inverse method. So what you do, if you want to convert a positive number into its negative, is take that positive 8-bit binary, start with the right-hand side, and you're copying, you might want to make a note of this, you're copying all the zeros up to and including the first one, okay, from the right-hand side. Copy all the zeros up unto and including the first one, and then inverse everything else. So here's a 0, we copy that. Here's the first one, I copy that. And everything else is inversed. That gives you minus 62 in 2's complement. Okay? I mean, obviously, the column headings, that would be representing a minus 128. But that would be your answer. And that will give you the 1 or 2 marks. Let's have a go at another one. Let's have a look at 55, and then we'll represent minus 55. Sometimes I find that this is probably an easy method to do and less likely to make mistakes when you're adding as you go along, as in the original method that I showed you. Convert the positive number and then just inverse to get the negative equivalent. It tends to be a very easy, less likely to make mistakes method. Right, so 55, let's start with 55 as a positive unsigned binary number. So that's 55. Okay, now if we're going to use the inverse method, and this works only with 2's complement, please don't try to apply this with sign and magnitude. It will not work for that. It's only for 2's complement. Okay, we're trying to represent minus 55 using 2's complement. We've got the positive number, okay, 55, and all we do is use the inverse method. So remember the rule, copy all the zeros from the right-hand side up until and including the first one. Now we don't have any zeros here, so we're going to copy the first one, and then we inverse everything else. 1 becomes 0, 1 becomes 0, 0 becomes 1, 0, 0, 1, 1. And if you check that, minus 128 plus 64 plus 8 plus 1 would give you minus 55. Right, I think that has explained everything that you need to know for 2's complement binary representation for negative numbers. What I will request, okay, is do please make sure that you click on the link below to access the worksheet where you can practice what you have learned today, as well as check your answers.